Good morning, everyone. I am Marie-Jeanne Lesot, professor at the Schedl University. I have been appointed to chair the PhD in terms of learning and cloud. Usually, the committee to assess your PhD defense is composed of a team leader with a remote session, a professor of artificial intelligence at the University of Queensland, Australia. And then the second reviewer is Gaël sitting here, professor at Telecom Paris, France. We then have two examiners, Markus Schedl, professor at Johannes Kepler University in Linz, in Austria, and Bauer of the University of Salzburg, also in Austria. And then we have two supervisors, Romain and Quin, from head of research at Deezer, and Vincent Vig, professor at AgroParisTech. So the PhD defense will be composed of two parts. In the first part, lasting around 45 minutes, you will present your work. It will turn to the question and answering session. So please.
Yeah, should be okay. Oh, wait, I didn't start the webinar. Whoops. Okay, forgot to activate. So welcome to people online that were waiting. They didn't allow you in. Okay. So let me start. So welcome everybody and welcome to my defense on interpretable music recommender systems. And thanks for being here. And I've been supervised by Romain Quin and Vincent Vig. Okay, I cannot change. I can change. Let's dive in. So first, what are music recommender systems? I think you all know the answer to this question because music streaming or streaming in internet-based streaming is the most common way that people engage with music today. And if you look at this top ranking, you will see that most of them are using personalization everywhere. And because this is 2023, in all these tech services, we have AI, artificial intelligence, that is used to, of course, for recommendation, but also behind the curtain to analyze audio, to analyze user sequences, or to tag metadata. So the usual selling pitch of recommendation is to say that we have catalogs of tens of millions of music tracks, and we want to help users by automatically serving them the music content, or at least this is the dominant paradigm in which we operate for recommendation, and this is definitely questionable, but at least this is how most people sell recommendation. So what's going wrong? Why interpret recommendations? I think you will be all familiar with a situation where you're listening to something and now wonder, why do they keep recommending me the same music track? And actually, funnily enough, we don't really know why we do keep recommending you the same music track, which should be surprising since we are the creators of these machine learning models. Why shouldn't we know how the model operates? And I think there are many entry points to this question, but one would be to highlight the difference between knowing and understanding. And a common example used to illustrate that is to talk about the Ptolemaic P-cycle system to predicting the position of planets in the sky that uses very complex trajectories versus the more modern physics understanding that is based on the law of physics from which the Earth is not the center of the universe and which we derive some trajectories that are circular. And that can apply to many different cases other than just predicting the position of planets in the sky. And we're pretty much in the same situation, at least according to me, for machine learning nowadays, because we can know very much how to predict your taste using transformers and big table of iterate predictions. But then this added step of understanding why you have this recommendation and why you would like or not like this recommendation is a completely different topic that requires a different approach, one of which is XAI, so explainable artificial intelligence. But of course, there are many different fields for doing so, like musicology, math, user studies, sociology, history, that may or may not be considered included in XAI or not. So essentially, in a nutshell, you're trying to get out of this situation where you have very confident prediction of what your music recommendation will be, but then as soon as you start asking why question, we don't really know how to answer them. So concretely, why ask why? So there are many also entry points to this question. One very common cited reason is talking about music recommender system is fairness, so addressing biases and representativity issues, which is a long conversation, but you could sum as considering all the involved stakeholders, user, artists, music labels, which can also slide to different topic, which is controlling, giving more agencies to user and artists. But interpretation is not only useful for fairness and understanding how this model work for the general public, but also, of course, for the tech stakeholder. Understanding how your model work may help you debug it, troubleshoot it, and check that this is more human-aligned, that it is not relying on so-called spurious correlation, so sketchy rational to make its predictions. One reason I really like is this quote by Grant Sanderson, who is a mathematician, who states, rather than trying to find a better solution to a particular problem you want, instead ask whether the problem that you're solving is actually the right problem to be solving. I think this pretty much resonates with many papers that I wrote. At least personally, that's how I approach explainability. And of course, this discussion is more general than just music recommender system, but for all machine learning, we have many regulations being put in place. In Europe, we have the GDPR, right to an explanation, or the more recent AI Act, and they all emphasize this need for transparency and the explainability of this model, particularly in high-stake setting for automatic decision, like the famous COMPASS model for recidivism risk estimation in the US. But we also have a French example, more recently in Le Monde, for pension prediction, where we have exactly the same kind of issues. And of course, I cannot not mention at least the generative model more recently, and the new arm that they entail, and they call for transparency to be able to know on what training data they have been trained. And yeah. And just to finish on a more positive outlook, maybe we can also use interpretability to discover new things along the way. For instance, in the DeepMind AlphaZero model that I've learned to beat every human at chess, now people are interpreting the past game of AlphaZero to learn new things about chess strategies. So maybe this is not all gloom to the need for interpretability. But okay, let's move back to the topic, interpretable music recommender systems. And okay, in addressing this topic, one issue is that there is actually not one, but many recommendation tasks. And there is not one, but many ways to process music. So this is just all to say that there is an exponential number of tasks and contexts, and thus it cannot be exhaustively addressed, this interpretability topic, because this is a gigantic topic. So I did not solve everything, unfortunately. Spoiler for the end of this presentation. But my research question was the following. What does interpretability mean in machine learning? How does it translate to music recommender system? And also a step back from also machine learning, what really is interpretability? And here is the list of some associated published work, as well as my part 3 of my manuscript, more devoted to this philosophy and social science and cognitive science part that is unpublished. So today we will mostly focus on this middle part. So I will explain later that we have studied interpretability in several contexts for several music modalities. So trying to interpret audio signals, sequences of track, similarity, embedding of embedding similarities, and yeah. And of course, because I have only 45 minutes, today presentation will be more restricted than what I did in my manuscript. So we'll study one very dominant method for explanation in XAI, which is feature attribution. And should I explain my system with feature attribution? And the outline will be the following. It has been organized as 4 stages of grief of using feature attribution method for explainability, from it seems to be working to actually what did we explain, and then 2 cases where actually we don't have features. So how do we use feature attribution and how do we explain? We need to find a different way. So if you don't know what feature attribution is, I'm going to explain all of that in this first part. Just to give you the general recommendation context, because again, there are several recommendation tasks, so we need to ground in a context. The first context we study is sequential recommendation, and in particular, skip prediction, which is something that is very common in the industry, but a bit less so in the academia. So I'm going to explain. So given a user history of listening to some tracks, I1 to I4, and we know that the user has listened to the track, for instance in green, or skipped the track, so click on the forward button. And given a list of next candidate generation, we want to predict if the user is going to listen or skip the track, listen to or skip the track. And so this is a skip prediction task. And of course, coming back to this difference between knowing and understanding, instead of just saying, oh, the user U is going to skip the music track I7, it might be more valuable to state why and understand why the user is skipping the track, understand what's going on badly, and also eventually modulate the recommendation generation to have better candidates. So how do we do that? One good entry point is to start from user studies and what we know on what the user do and why they do skip the music. So we have many questionnaires and things that has been done at Deezer and many streaming industries to try to understand why people skip the music. And for the sake of the presentation, I will just reduce to 4 cases that will illustrate the issue well. So 4 situations, for instance, I skip the music because it doesn't match the rest of the sequence or the context, or because I've heard it too much, or I hate it generally, which can happen. And I'm just exploring and skipping through the content. So for instance, going through a playlist and clicking skip all the time. And you can already see that this situation do not have at all the same implication for the interpretation of the skip. Well, the I hate it generally should be interpreted as very negative, while I'm just exploring and skipping from content is way more neutral. So how do we detect this situation? One good proxy is to notice that in these 4 situations, they are appealing to different aspects of the input features. So the first one is more appealing to musical coherence, the second to repetition counts, the third one to adequation with a general user profile, and the last one to activity patterns and detecting what's going on the app. So the big assumption is, well, maybe we don't have the label to train and detect the situation, but maybe we can make the assumption that we can reduce the detection of the situation to the feature they are based off. So finding a reason for the skip I7 as stating, is it linked to musical coherence, to repetition, user profile, or activity pattern? And this is exactly how you come to the topic of feature attribution, which is exactly solving that. And that's one of the most popular methods in explainability. And there are actually many names for the same method for feature attribution. But in general, you can state that there is a sort of general framework common to all these methods, that you have an input explanation space, X, on which you have defined some atom of explanation that I will define later. Then you have a computation process, usually your recommender system, and an output to explain, Y. And your goal is to find an explanation E that will be scores of influence ranking those atom explanation in explaining the dependence between X and Y. So I talked about atom of explanation because actually, if you consider, for instance, all the pixels in an image, you will find your score influence as looking at this, what we call silencing maps, and as well as a big class of gradient-based methods. But you can also consider superpixels in an image, and you arrive at the method of Lyman-Schaap. You could also consider sample in your training sets and have influence function, this class of method, as well as neuron in a neural network, and arrive at the concept learning literature, even if it's a bit more blurry than that, but that's the general idea. Okay, so coming back to our problem, we have our inputs that we will split into 4 groups of coherent features, so the musical features, the repetition linked features, user profile, and the activity. And we have processed it through our model and predicted that, for instance, there are going to be a skip on I7. Then our goal now is to use feature attribution to say that, okay, we are going to have a vector and only this purple group is necessary to predict that there are going to be a skip. And then we'll conclude that, oh, the explanation is the skip is due to the activity, for instance. And how do we do that? Actually, there is not many methods for group attribution. So this was my first paper published at Praxis, trying to address this exact question. And the general overview is this is a group plus hierarchy attribution method. And if you know the class of explanation method, this is an intrinsically interpretable model compared to post-hoc explainability, just for people who know what this means. And okay, so the general explanation of how it works, just in a simple case, is you have all these four color of input group. You will train several experts to predict the skips or non-skip. Each one will have a prediction, Y1 to Y4, with some scores. And you will notice that, well, this one is the most confident prediction because it's the closest to 1 or 0, so skip or non-skip. And you will conclude that the skip is due to the user profile coherence. By comparison to the first group, for instance, where it's a 50-50 chance, so you cannot leverage these features for prediction. And of course, this is way more complicated in reality because you want to also handle overlapping groups and maybe a hierarchical view of combining several of these current features. So we've used a boosting formulation to address that. And also, I mentioned that we have expert predictors, so you need a mixture of experts to have a final prediction. So I'm skipping over the detail, but we use an expectation maximization algorithm. We have a masking trick to actually emulate all this mixture of experts directly inside the deep learning model, which is pretty nice. And then we are able to formulate an attributable transformer model because this is very hype. And of course, one of the selling pitch is you want to tell people, oh, you can switch your deep learning model by an interpretable one without degrading the prediction performances, while having this new free lunch of, no, I can explain my prediction. So this was one of the objectives of the paper. And I will just jump to the results just to show you. And okay, before jumping to the results, just note that this is not so much about the method than it is about the approach. At least I try to make it that way. So what we want ideally is, again, coming back to the skip prediction, be able to say, oh, there is going to be a skip, and this is because the user heard it too much compared to not knowing anything. What we get in practice is given a half session where we know that the user mostly listens to rock tracks, and a candidate, next candidate generation for 10 tracks, we can predict some skips. And then we have some attribution scores where, so I will not go through all the list, but for instance, in this track B5, it was actually a Malaysian pop track, which breaks the coherence with the rest of the session, which was mostly rock track. And you can see that one of the expert activating was more linked to musical features. So it seems to correspond to this idea that we activated a musical skip. But of course, this is a bit sketchy. And as a wrap-up, we found that most skips are actually linked to very unclear interaction pattern. Surprisingly, they rely on very few features to be predicted. And this highlights one of the big difficulties of using feature attribution, which is that we started from many cases of skip, and we said, okay, let's make the big assumption that we can reduce to only what feature they are using. But then going the reverse path from these features to the original cases, and maybe there are other cases, is actually not so trivial. And when you find that you can predict a skip with very few features, you can wonder, what situation does this correspond to? There is a very good paper by Apole-san highlighting also the problematic phase in number. And what I mean by that is when you have a table like that, are we not creating this value of explanation in ourselves when we interpret this table, or did we really detect where we want to detect? And as such, just with what we have, this is not so much insertable. So, which led me to the step 2 of what did we really explain, the explanation of explanation method. So we were a bit sad using attribution methods because it didn't feel so fulfilling. And actually going to Praxis, my first conference for this PhD, and talking to many people working with attribution methods, I had the feeling that many people were also lost and not being sure what were exactly the values of attribution methods. And of course, in parallel to that, there are many papers critiquing attribution method and all the method of attribution, even also attention, which was very hype at that time, and also the field of explainability in general and calling for more rigorous science. And just to give you a taste of what's going wrong, among many examples, saliency maps is one of the most popular methods for explainability. So this is the same graph as before, but just simplified for what attribution is. You have your input X, your model that process prediction Y, and you want to compute till your vector of score, stating which features in orange are the most important to predict Y. So you can state that Y is f of x, to simplify. And what saliency maps propose to do as explanation is to say that the explanation will be the gradient of f given the input, so the derivative given each input. But then if you start to ask, well, why would the explanation be the gradient? And you read the paper, you just have written, this is the first order Taylor expansion, which in my opinion is a bit redundant with saying this is a gradient. And this highlights a big issue that we have in many XAI paper, that we have a lot of methods, but it's not so clear what exact explanation task we are trying to solve. And yet, just to give you more interrogation, comparing explanation given by artificial methods to real explanation, we don't really know how to address confidence level for the explanation. We don't know how to ask for alternative explanations, or for clarification, or of course to compare the different methods. How do you compare the saliency maps to SHAP or LIME? We don't really know. With just having, I'm just a gradient, you cannot say just with this information. Okay, so my point would be to state that in general, we lack a philosophy behind the method to encompass all those examples. And speaking about philosophy, actually, I've studied this literature a lot, and you can find many answers actually in the philosophy of explanation that have been studying this model, sorry, not model, but this topic of explanation for a long time. Okay, so it's a vast literature, but as some key points, explanation is actually both a product and a process. And what I mean by that is that there is, of course, the part where you produce some explanation, which is what XIA has mostly been focused on, generative method for generating explanation. But this is forgetting about then the interpretation process and the understanding part. Maybe you may or may not understand the explanation and have a back and forth with the one explaining, and also the more general context that you have an explainer, the one giving the explanation, and the explaining, the one receiving the explanation. You can also study the, okay, let me move that, the explanandum, the thing that you try to explain, and also the post question, because asking why P is different than why P rather than Q, or how come that you know that P, or many different questions. And actually, we don't know what is a post question in many XAI methods. So if you need to just remember one punchline, is that you don't just explain, you explain to someone among many other components, of course. So this is what motivated me to propose not a method, but a theory, and trying to unify these several explanation methods. So of course, this does not address everything, but arguably this is the first step to trying to explain what's behind these methods. So this is going to be a bit mathy, but stay with me. This is really the worst part. So this is coming back again, the same figure of attribution. And the way that attribution is often presented, the task is we are trying to find a set of indices S such that Y is equal to Fx depends on. And usually the big mystery is what this dependence means. And it often depends on the method. And so what we propose to state in this paper, that, well, don't we mean functionally depend by any chance? And what I mean by that is stating that if you have, let me move this thing, it's a bit annoying. For all input sample in the input distribution, you have a function that depends on n variable, x1 to xn. And if we want to state that, for instance, dependence in this is in these two indices, 1 and 3, don't we mean by that that the function is actually equal to different function, f prime, that only depends on two variables? So, and if you start fiddling around with this equation, actually the gradients start making sense, because for all the indices that are not in this dependence topic, the dependence subset, the gradient will be equal to 0, because by definition they will be constant. So you can say that actually the gradient makes sense if you have this functionality view, because it retrieves the non-functional dependent features. Okay, so this is promising, and you can also, I'm skipping over detail, but you can also explain many other methods. But this was encouraging, at least. And just to say it differently, if you have a function and you say that y, so prediction, is attributed to the input indices s is equal to 1, 3, what we may state by that is that this function, you can replace all the variables that are not 1, 3 by an interrogation point. And the value in this interrogation point do not matter to determine the output. So of course, interrogation points, they do not really exist in math, so we can express that more vigorously. I will not read all that, but just to say that there is some real math behind that, trust me. And this was a global case where for all input samples, you try to find dependence. But now we are going to move to the local case, so where the dependencies can depend on the sample you consider, which is way more common in explainability. So what we consider is a simpler function, f, that only depends on two variables, x1 and x2. And let's say that we are trying to find a function such that on the first input, 0, 0, the function will be equal to 1, and the dependence will be in the two variables, 1, 2. And the second sample that we consider, 0, 1, the function will be equal to 2, and the dependence will be only on the first variables. So if we rewrite that with n-waving definition of integration point, we are trying to find the functions that obey these constraints. And actually, we'll find that there is a problem with that, because we say that we can replace by whatever we want, but if we replace by a 0, then we have that f0, 0 is both equal to 1 and 2. So there is actually a big lesson here already that if you have local attribution, they actually must have a global coherence. You cannot have whatever explanation you want on each sample and not expect to have a global coherence to achieve, which actually makes a lot of sense. If you predict that there is a cat in this picture and that this group of pixels is the most important and that the rest can be interrogation point, can be replaced by whatever you want, what we are claiming is that if you indeed replace by whatever you want, you still have a cat in the picture. This is just stating that. So you have some functions that are incoherent because you have conflicts, and you have some functions that are coherent where you don't have these kind of conflicts. And using this idea and formalizing a little more, you can define actually a definition of what local attribution might be as a problem using this functional dependence notion, which will be, not entering too much into the details, the minimum of this coherent solution that adheres to the data. But more importantly, we can actually now use synthetic data to generate 1,000 ground truth function for which we know those local dependencies with 2 features, 3 features, up to 11 features. And now we can actually see, let's check if those attribution methods retrieve these ground truth dependencies. And I'm asking now this open question. I don't have the answer to that. If not, you say don't retrieve the functional dependencies. What do they retrieve? And the table, the only one in this presentation, will be the following. So we have listed a lot of common XA methods. So here you have widely popular methods like Lime, SHAP, and integrated gradient with a lot of citations. We have some more older methods like Shapley values, the original formulation, not SHAP, and some generalized additive model with infinite order of interactions, and as well as lower order of interactions. And yeah, some selector predictor method, but they didn't work so well. And the results are the following. If you try to find if they retrieve the correct local dependencies, actually the winning methods are, unsurprisingly, the NP computation methods. Oh, by the way, our method in the previous step did not fare so bad, which is pretty good. And the popular methods, actually, they do not fare so well. So 3 times over 4, they do not retrieve the correct dependencies. So this is really hard to say mathematically wrong, but I don't know how to formulate it differently. And yeah, also one interesting property is that if you start looking at the solution they provide and look if they are self-coherent or not, and on all the points, you will find that this table of property verification rate actually correlates with this previous table of attribution accuracy, which is actually interesting because verifying this property does not require to have access to this ground truth on synthetic task. So that may be used to more realistic scenarios. Okay, let me wrap up on this math section. Okay, just remember that prediction performance is not a guarantee on attribution performance because in the previous table, we always add the same model for prediction, but you can see that the explanation performance varies widely depending on the method of explanation you use. So don't trust the citation and wonder what's behind the equation. Also check the assumption. Actually, if you read the paper for Lime and Chap, you will see that they rely on the assumption of feature independence, which is a bit wild for deep learning. And of course, maybe to nuance everything I said, there may be still cases where this attribution thing is okay. If you're trying to explore your data or debug your model or do some coarse analysis of what's going on, you may, of course, still retrieve some interesting stuff. I'm not saying that everything is doomed, but just be careful if you're trying to make claim on reality, for instance, move from model explanation to reality. And of course, it still does not address the question. So we've been talking about attribution, but is it actually an explanation? And is it actually a good explanation? And is it an appropriate explanation? So we're going to move to the last part of this presentation. So I will be quicker for my 2 last paper of cases where feature attribution is actually not applicable at all. So first one, my feature do not make sense. What do I do? Okay, so we've seen that feature attribution sort of emerged naturally for considering sequences of log and interpreting features and metadata because you can group them in coherent sets. But now you can wonder, because we are working with music, what about interpreting audio and audio signals and spectrograms? So let's put yourself in this situation, in this context, where you're a user listening to some music and you ask your app, I want to listen to workout songs. So Deezer say, sure, here are some recommendations. And then we play a very sad song. So then you're not happy with that. And you say, okay, I don't want to work out anymore. And you're left with no music and no muscles. And you unsubscribe from the service. So what did happen? So this is tragic. And on the next day, an engineer load the incremented track, music track A, computes the spectrogram. So it's a time frequency representation. And say, okay, our model indeed predicts that this is a workout song, but why exactly? So naively, they run feature attribution explanation methods. And what they find is the feature attribution map that, oh, this is a workout song because these bits of spectrograms, which is not an amazing explanation for a number of reasons. One of which is you may not know what you're looking for, trying to debug why this is a workout song. If you don't know what could be the spurious correlation, for instance, you may not know what you're trying to look for. And if for the sake of the example, we say that our model failed because it was detecting fast tempo in the track, what could be the ground truth attribution of highlighting fast tempo in a spectrogram? This is not so obvious. If you think of rock song, or for instance, detecting that there is a French singer compared to a British singer, how do you express that with a spectrogram? So this is an issue that is not only common in a recommendation system, but also in a larger music machine learning. And this has motivated to introduce a new paradigm of explanation, concept learning, which was introduced by Ben Kim and the TCAV method. And just to go quickly, the general principle is to state that you have your input space, X as before, your model that predicts something in the input space, output space Y. And the idea of concept learning is to embed this input space into a concept space that supposedly is more aligned with human understanding of this data, and then to make the explanation from this concept space C instead of the input space. So the big lesson is it doesn't have to be the same space, the one you use for prediction and for explanation. And okay, so this had not been done in a music information retrieval before. So this is what motivated us to write this paper for Izmir, of trying to port this method of concept learning to the realm of music and seeing what are the challenges in adapting that to music. So again, the goal is, instead of processing music as spectrogram, processing them in a different space where you have more interesting information. So just to go over how we do concept learning very quick, so that everybody understands what we are talking about. The idea is to have a backbone model, so that you want to study, predicting workload song, for instance. And you suppose that you have some positive example of this concept, for instance, funk, you're trying to detect. So you will embed these samples into a latent space of this model, as well as some negative samples, compute a regression on it with a direction vector. And you will conclude that the model is sensitive to this concept. Actually, you can detect that in the direction VC. Of course, you can check with the accuracy of the regression if you detect this concept or not at all in the model. So this is actually all there is to know about concept learning. This is a linear probe of the model. And now moving to music, well, you can wonder what is a good concept space for music? How do we build this concept space? And what we propose to do in this paper is to rely on playlists, which can be seen as a sort of folksonomy. Why playlist? Because actually there are playlists for all the possible genre and era, also for many moods, and for even more niche sounds of cities, and even more niche musical concepts. And so the key research challenges is, of course, if you use playlists, this is going to be very noisy, especially if you use user playlists. It's also not going to be an orthogonal decomposition, which has not been considered in the concept learning literature before, because in music, you can have funk music, you can have rock music, but you have also funk rock. So everything is intertwined. That led us to propose to studying a new task, which is learning a hierarchy of concepts, which was new. And of course, computing that in an efficient manner, defining a measure of concept similarity. And what we ended up doing is finding a method from natural language processing and adapting it to music, and showing that it was relevant to adapt this method. And of course, the big question mark is, how do you evaluate this hierarchy, which was a big chunk of the paper, trying to evaluate that. So I don't have the time to present so much details, but let me just jump to the visual results. So from a dataset of playlists from APM Music with 200 playlists, we can indeed compute a sort of hierarchy. And if you zoom in, you can find that you can hierarchize this Latin influence playlist, Latin music, Calypso, and Latin dance style. So this is encouraging on this example. And you can also try to do it for many Deezer playlists, so 3,500 of them. And this is way more messy. But if you want actually to, if you want to explore this hierarchy, actually it's available online, where you can see what's going on in the hierarchy and explore and click and access the playlist. So this is definitely not perfect, but this was, first try at that. So just to jump to the discussion, of course, this method is culturally biased because we are relying on playlists and our users are not representative of everybody around the earth. It's also model biased because you rely on a backbone model, which may or may not represent interesting concept for music. I will also skip on the evaluation, but it was pretty difficult to evaluate. You don't have necessarily ground truth for your whole hierarchy that you try to mine. And I will just highlight that actually, just to highlight the difficulty of the task, finding a hierarchy is pretty hard, because if you have a graph with 3,000 nodes, finding a tree in that graph, you have 3,000 to the power of 3,000 possibilities. So that's 1 followed by 10,000 zeros of possibilities of hierarchies. If there is only one ground truth, of course, but yeah, just to highlight that there is a lot of possibilities. So yeah, in conclusion, it was very much exploratory. It was one of the first methods trying to do that. So there is a lot of things that are not going well, but there are also a lot of things that are actually pretty interesting. First, it's a promising alternative to feature attribution. Also, playlists are very interesting for human alignment because that's how user and expert editors describe the music organically. It is tunable. If you want to add a new concept that you find is interesting for explanation, you can just create a playlist and then it's added to the graph. And just one unintended side effect, it's that it was actually nice to play with this hierarchy and explore the music, which may open to different questions, like this paper on the small in the bottom, taste path, where they study the use of graph for exploration and discovering new music. Okay, and let's move to the last part. I don't have features. How do I do feature attribution? Again, so we said that, coming back to this general graph, feature attribution was probably relevant for sequences of log features, and that if you have audio and sort of a semantic gap or high-level information or intermediate level of information, maybe it's more useful to use a different approach like concept learning. But now what about this last modality that is very common in music recommendation, embeddings? So music embeddings, for those who don't know, are at the core of many music recommender system. And the idea is just, this is a transformation of music into a list of vectors. So if you have Stevie Wonder's vision, you will transform it as a blunt list of numbers, and you will embed all your catalog into a 9-dimensional space where each point represents a music track. And the issue with doing so is that this is very convenient to process for artificial models, but you are hitting a wall of interpretability because you're transforming some explicit information of the tracks, the name, the artist, and how it is organized in collection into a big matrix of numbers that don't necessarily have a meaning. And then it's really hard to go back to the original formulation. So for instance, coming back to this eternal figure of attribution, just to demonstrate it, if we input again Stevie Wonder's vision represented as a list to the model and say, okay, this is a good song and here are all the reasons. And this is a good song because it depends on minus 0.5. Again, this is not a good explanation. Because the input features do not really have a meaning taken in isolation. The thing with using embeddings is that only the structure matter and the similarity between the points, but not really each dimension of the embeddings. Which led many people to think that, well, embeddings are seemingly uninterpretable, so is explanation doomed as soon as we use embedding? Not until this paper. No, of course, it was published at Rexis 2023. Okay, so I will skip over the details, but we are studying the singular value decomposition to process embeddings, and there are a number of reasons for doing so. One of which is because we have a rich theory on the SVD, and we can derive some theorems. And okay, so this paper started from an observation that actually if you compute some embeddings for music tracks on Deezer and you plot them, some of the coordinates, so 0, 1, 2, so all of that are points, and you can find that very strikingly, they tend to self-organize along a line that pass through the origin. And this is even more surprising because this is not only true for Deezer, but for many other datasets, including Spotify, Art of the Mix, Cornell, Last.fm, and also the very famous Movie Lens dataset that we use all the time in the Rexis community, which led to which begs the question: is it an artifact or is it something interesting? And I will skip over the detail, but if you started studying this effect, and you can actually prove that there is something going on from a mathematical level. And okay, so I will explain that with n-waving definition. So let's say that you have your embedding that is structured with this spiking structure, and maybe a part of it is just random noise. If you compute the matrix of similarity of this embedding space and reindex your indices, you will find that each spike will represent a big block, and that you have a matrix that is diagonal by block, where you have a correction where some terms are higher than the others. And this is very striking because this matrix is exactly what we call in graph theory a degree-corrected stochastic block model, which is a model for community detection. So actually, you can state that, well, actually, these spikes represent communities. And when you compute a singular value decomposition, what you're implicitly trying to do is reconstruct the communities that you have in your data. So community in the sense of in your group, you have more probability of linking with your element in the group than outside of the group. And even more interestingly, because this is a degree-corrected stochastic block model, you can find that the norm in your spike represents intra-popularity. So if you are an influencer in your group versus a more niche artist, you will be closer or further away from the origin. So this is actually very interesting because we started from a very mathematical theorem and found something that makes a lot of sense for music. Namely, you have communities and you have several degrees of intra-popularity. And this has some practical implication. For instance, a very common question in information retrieval is, should you use the dot product or the cosine measure for retrieving the elements? And so, for instance, if you use dot product using this formulation with spikes, you can say that, okay, you will retrieve this red element. And you can see that this is mostly the popular element in the communities, but spread between different communities. So you have a popularity bias, but maybe exploring nearby communities. And if you use a cosine measure, you will retrieve only the spike because it's at a zero angle and with no let's say, importance for the intra-popularity, but then you don't retrieve that much the other communities. So it's maybe more fair, but you create filter bubbles. And having this view, you can also craft new metric, like retrieving similar music, but that is more niche. So giving this element, finding something that is in the same spike, but closer to the origin by just subtracting the two metrics. Yeah, this is just for the sake of the demonstration. But yeah, using this theory, you can maybe do a lot of stuff. So as a wrap-up, we can still explain actually, but differently, using a theory, which is appealing to the unification conception of explanation, if you want to be philosophical about it. And I really like that it started very mathematical and stating that there is an artifact and then going to something that is very human, practical, and cultural. There are communities. And again, as many of my work, this was very much exploratory and opens the door to many other implications. The stability of the embedding space, using it for exploration, maybe using it for checking representativity. Do we have all the communities or some of the communities fused in just one, or are you lacking some communities? So yeah, a lot of questions. And let me move to the conclusion. So coming back to the first question, should I explain my system with feature attribution? It depends. If you have sequences of log or feature and metadata, yes, there may be cases where feature attribution can be useful, even if there are some many open questions, like does it represent a functional dependence or maybe something else? If you have audio, maybe it's more appropriate to use concept learning, and in general, concept learning is very promising to have more human alignment for explanation, which is a big topic. If you have embeddings, maybe you need a completely different approach as creating a new theory for it. And of course, there are a lot of uncharted territories that I didn't study in my manuscript, and for which I don't have the answers yet, or we don't have the answer yet, generally as a research community. Okay, so just some general takeaways for people working in machine learning. If you try to explain your model, try to formalize some explanation goal, and at least try to do an explanation task and list all the stakeholders impacted by your model, which will help. Wonder how human would explain this. Adopt previous methods, beware of the fast food culture of XA, which is a term that I owe to Paul Essan, which was really good, I found. And also read from different fields. For instance, I read a lot of philosophy, cognitive science, and explainability in medicine field, and there are a lot of valuable stuff to take from those fields outside of machine learning. Of course, you can read my manuscript if you want to have a digest of all these things. And okay, moving away from this advertisement, some perspective. I've not implemented a lot of things in the product. This is a page where I self-critique my work, which of course lacks a lot in terms of interfaces and connected user study to see the other part, this interpretation, understanding, and the practical worth of these explanation methods. I also talk a lot about causality in my manuscript, but I didn't publish any paper on causality, but I still think it's an interesting direction. And also wink to Markus Schedl. The psychology grounded model are also, I think, very valuable to try to have a sort of different approach to how we recommend music. yeah, and having a different theory for that. And yeah, that's everything for me. Thanks for listening.
So now we start the question, and the one to get them up with the room.
Okay, thank you very much for giving me the floor.
Yeah, let me just check. Can you, Markus and Tim, hear the question right? If you speak.
Yeah, mostly. It's a little bit hard, but I can hear enough.
Yeah, same here. It's very quiet and noisy.
So I'll try to speak out then.
Yeah.
Okay, so first, thank you for inviting me to this jury, and thank you for your presentation. I think in overall, when you read the document, of course, it's not a very small document, so you need time to read it. But what is sure is that it's very well written, very well argumented, and very well structured. So it's surely a pleasure to read such a document, and you can see that there is quite some thoughts and quite some deepness in this document, and that you have really thoroughly studied the problem of explainability, interpretability, and in the scope of music recommender systems. So of course, this is the very first thing that I wanted to say. And when we listen to your presentation, I also can feel that you have quite some background and deep knowledge of the field. That you spend quite some effort to think about the question and not only doing a system that does a bit better than the others. At least there is a strong intent for that.
Yes. There is an intent.
So I do not have, and also what is also quite nice in your document is that in fact it will be quite to see the problem with a very narrow point of view. If you had seen the problem only from the computer science point of view, I would say, and in fact, the question you ask yourself and you ask in your work are very interdisciplinary. And again, you have looked in many domains to fuel your work and to grasp ideas and to go forward. And I think this is quite impressive because, in fact, interdisciplinary, multidisciplinary is always very difficult. Everyone wants to do it, and maybe many claims to do it, but very few are really doing that and reading the literatures in all the domains and seek for exploiting this idea from the different domains. So I think this was very nice, and I have a few questions, and I would need a few explanations actually. It's good we are in the topic, and so then I think it will lead to a few discussion on some of the aspects of your work. So my first question will go to the work you described in chapter 3, where you try to interpret logs of users. And I'm not sure I have well understand, and so that's why I will need an explanation of the notion of expert and individual expert and why you have a parallel expert. From what I understood from your presentation is that you have one expert per domain or per group of features. So my first question is that the case? You have one domain per group of experts, and if it's the case, how you define these domains? How you define one expert for this domain, for this group of features? It seems a bit.
Yes. So it was actually encrafted. And I think this is actually okay. So it always sounds a bit weird to say it's encrafted, but I would reverse it, say it a different way. That it's actually interesting to input yourself as a bias and saying, no, you have the agency and you have the role of crafting these different groups, and then defining. Yeah, this is a point where I should have added some slides. But yeah, you define yourself this group of current features, which is often not so difficult to do that because you know what are your musical features, your user-related features. But then the group of interests, which I call group for explanation groups, then you can define them yourself. And so if your explanation task calls for detecting musical features, then you add them in your method. If it calls for studying something different, you can put it. One interesting aspect is also you can adapt the coarseness or the fineness of the explanation. If you want to have something that is more fine, you can have more groups or something larger. And you can also retrain with different groups. So I think this is very dynamic in some ways. It initially started as I have this simplifying assumption that I know what group I will expect to find because I knew this sort of situation that I was showing at the beginning. So there is more than 4, you can actually define 10 situations and trying to see how that could translate to express that in terms of what features I can detect and then translate those into this problem and stating that, oh, we don't need to run the full feature attribution and stating that just feature 1 and feature 100, they are almost silent. We are mostly interested in to what group of features interesting. So it's completely tunable, and it's even encouraged to be tunable and to require human priors, human expertise, I would say. So that's also the point. It's not automatically. Actually, I've tried to automatically craft this group. Which I've not at all put in my manuscript, and it was during my first internship at Deezer. It was pretty difficult because if you try thinking about hierarchy and trying to define the subsets, you are trying to define the notion of you need to gradient ascent of this subset, and then you have blurry subset, the fuzzy subset. I think we translate in English. And then you need to have a notion of fuzzy inclusion, fuzzy hierarchy, and it gets a bit messy. It was a bit working, but also then suddenly you use all your, I need this human prior, I know that it makes sense, and you retrieve some groups that don't necessarily make sense. You fall again into this problem of, okay, I have automatically learned my group, but then I have a lot of groups that don't necessarily make sense. Of course, you can critique that this is because I've badly regularized my problem, and maybe you can put other priors to learn automatically the groups. But yeah, I've tried to do it automatically to find this group in an efficient manner, but I didn't find something that was, at least given what I did and at the point at which I researched this automatic detection, sufficient or satisfying. So that's why I stayed at this. Let's define the group and say that, okay, we actually know we don't need automatic group detection and train the expert on them.
Okay, very, very good. You even answered, you even answered the question I did not ask, but which I was going to ask next, so then you should skip this question.
On the automatic detection, right?
Yes. Yeah. The automatic group. I mean, in fact, if you embed some prior knowledge, you can say, okay, you have machine learning, lots of data, and maybe you can, in fact, find these groups in an automatic way. It's maybe not smarter, but in an automatic way.
Yeah.
And so then that's why my question. Okay, so then another question related to this point. So then you have one expert per group.
Yes.
You say that it's that the learning is done in parallel, which means you believe that each expert is completely independent of the other. They work completely independent. I mean, there is no relation between the experts. There is no gain in, for example, learning all experts jointly in a way that they may take some, they may take some information from another group or.
No, so actually there is some dependencies between the experts. So what I showed you was a simple case where we have non-overlapping groups, but in the general case, you consider that you may have a hierarchy of groups. Okay, this is I don't have the equation for residuals, but what I can show you, for instance, my overview picture here. So it was way more complicated to understand if you consider the context. But okay, so we have, for instance, here 2 groups, and we defined 2 what I call explanation group. S1 that is just relying on this first orange group, S2 relying on the red one, and S3 a third expert that is relying on both. And the idea is that you can instill that inside the model. And okay, what you will do schematically is to first train the leaf group, And then on top of that, you use the boosting to train on the group, on the expert that depends on two subgroups. So first you will train schematically the S1 and S2, and then you will train the S3 based on the residuals, and you can use actually some links of what is inside the latent space of this S1 and S2. So you can leverage this knowledge from the different experts. But so this is a principle, but in practice, we do find a way to train everything jointly at the same time, but while still preserving this hierarchical dependence with the S3 learning at the same time from S1 and S2, but not the other way wrong, or else you contaminate the dependencies. But yeah, so that's because actually this is inspired from the method GAM2 by Lou Korana, and I think it's like based on a generative additive model. So the normal generative additive model, generalized additive model, sorry, is based on computing univariate experts and combining everything. So basing on just one feature computing and then combining everything. And what they did propose to do in the paper is to, okay, we can now train on the residual and train bivariate experts or the bivariates. And then we have the information for if the prediction on the univariate feature was not sufficient. And so they trained sequentially by having first the univariate, then the bivariate, then the trivariate, and quadrivariate. I don't know how we say that. And instead of doing so, we said, okay, using a boosting mechanism and using a special selection function that you may remember from the main script, the alpha functions, you can instill this boosting and residual mechanism directly during the training and trying to train everything jointly. So this was one of the contributions of this paper to try to do more.
Okay, so maybe the last question on this point, you have as many experts and concept and group to highlight.
Yeah.
And then the question is, why can't you have more experts and then you will still explain groups, but by combination of expert outputs, that the expert will be a bigger crowd of experts, but they will not be only giving information for one group, but they may combine their feeling, as you say, or their opinion. So then they can, well, so that's the question. Can you use more experts and groups or different, I mean, that you do not tie the number of experts to the number of groups you want to?
At least not with the formulation I did, because the core of the method is to do I have an equation, this one equation. Okay, I know. Maybe here. Okay, so the expert are F, it's one of them, if Fm, sorry. And the idea is that you restrict each one on the distribution. So the built-in assumption is, of course, that one expert corresponds to one group. So I don't know how I will proceed to have more experts, but then telling something on many different groups. But it's probably a different approach in some ways. But I think the core thing was to say that each expert tells something what you can predict in the restriction. Then you sort of try to catch which one is the most confident. This is why it was built in that the expert represents this dependence. So there is probably a way to do it with many experts and trying to maybe combine in a smart way the aggregation. Okay, actually that may be reminiscent of the archipelago method by Michael Sang, if I remember the name properly. And the idea was to do so this same principle I said about training of univariate and bivariate model, and then so they have just this input expert if you want, and then they do a union find, so you combine all the bivariate that overlap to create, if you have all these bivariate responding bivariate, combining it to a larger group. And this is one of the methods I evaluated, and actually it works pretty well. If you don't have, of course, a third order interaction, but if you assume that your function is smooth enough so that you have all the bivariate interaction, if you have the trivariate interaction, that may be a way to, this one, archipelago. Oh, there is no name. And yeah, you can see that it performs actually almost as well as our method. So it was actually a very cool trick, the archipelago one. And that may be one way to do what you say of, I need more, less expert, and then reducing more stuff on the attribution.
Yeah, each expert will see only a subset of the information from a group, and they are still assigned to groups, but they will only express one part of the subgroup. I don't know that. Well, anyway, thank you for the explanation. And let's move to another aspect, to maybe linked to what you described about interpreting music signals, yes, and to this notion of unsupervised hierarchies of concepts.
Yes.
So you mentioned that it's difficult, and you gave a very nice illustration on your presentation, that it's difficult to give an explanation to spectrograms. Then my first point would be, yes, maybe for the general public, because you first have to explain what is a spectrogram. It's maybe not obvious for everyone what is a spectrogram. But here, from what I understood from your speech, is that it's an explanation for the experts within Deezer, for them to know what is the method is working or not, and it's not really an explanation for the final user. And in fact, I remember that in the old days, when we were looking for spectrogram in speech, if you became quite good in reading spectrograms, you would have been able to really understand what was uttered, what was pronounced, just by looking at the spectrogram, which in a way means that you can give explanation just by looking at spectrogram if you are an expert in spectrogram. So then that's my first remark. And the second remark on that is that spectrogram, if you extract meaningful parts of spectrogram, maybe you could render the spectrogram in a way that it will be more explainable to user. And in fact, we're talking here about audio. So why not play the rendering in the audio domain of the explanation that you see on the spectrogram, which is not really explainable by seeing it, but maybe by listening it is more explainable. So that's my question.
Yes, good question. So I'm not, I don't think expert as you to be able to read from the spectrogram. And yeah, I think one first counter argument is, yeah, but we don't want to talk just to expert, you know, easy counter arguments. I still think that some things might not be readable from the program, and that in any case, if you have different decomposition. And also the thing is, if you don't know what you're looking for, also it may be difficult to really read from the spectrogram what you're trying to detect. If you're aware of the potential spurious correlation and biases, you may be able to do that. But maybe if you don't know exactly what you're looking for, of course you can listen to it. And actually, there was, okay, I cited here Lemons by Alessandro Melchiorre, which was one of my co-authors, which is exactly that. That's applying the LIME method, and then I don't know if they generate the spectrogram or just try to read it directly. And they think, okay, we generate essentially source separation based explanation where you have bits of the spectrogram and then you can play it. But I think that my point would be that it's still limited to some application. Of course, if you're trying to say that there is rock music because you have guitar in the sample, yes, of course, attribution will work and you can play it and then you say, oh, I get it, it's detecting the guitar. But more generally, for more concept, we can think of the fast tempo. Okay, fast tempo, you can probably still read it. But again, if you don't know that you're looking for the fast tempo, maybe it's difficult to find. So I don't know how to answer exactly. I'm not saying that feature attribution doesn't work at all and reading spectrogram is bad, but it's more about finding new ways if you have this more semantic gap concept that you're trying to find, or to when you work around that. And also one often common issue with attribution is if you have superposed concept in the same frequency band of the spectrogram. So the example, okay, maybe it's not the most visible with spectrogram, but if you think of images, and if you say the example of TCAV is often, I have this zebra that I try to detect in the picture. And why is it a zebra? If you run the attribution, we essentially just segment the zebra. But while what the model is trying to detect is there is a stripe concept. And so if you just highlight the attribution, you will say, oh, the explanation is there is a zebra because there is a zebra. But while what the model is looking at it, there are some legs, there are some stripes, so you have a lot of overlapped things, more than, you know, more dimensional than maybe just the attribution. To be, I think, my point of how, you know, concept learning can help with that. I'm not saying that this is the absolute answer, of course, but this is at least a different paradigm to sort of overcome some of the difficulties in becoming an expert in spectral reading.
Okay, thank you. Maybe I can ask maybe a last question. I think so then I can leave more time to the others or to the other members of the jury. Linked to this notion of concept, something I did not understand is that you build concept from playlist, and then it looks like you organize your catalog within this concept. I mean, within this hierarchy you found. But what I did not understand is that do you suppose, in a way, that one music piece, one recording, is only in one playlist, or is it in multiple playlists? So then, how do you how it is shared between the concept? Because of course the title of the playlist will be different, and but it will be the same music, and I guess that this happens a lot. So how do you define this positive, negative example, which that was not very clear to me? And yes, so are all the playlists completely orthogonal?
Yeah, so as a matter of fact, the dataset that we use, there is little overlap, so in the case, but there are still some overlaps. And yeah, so I had read this question from your report, and I think the best analogy I can find to why this is still not a problem, to have some positive samples that are also negative samples for a different playlist, but actually in the playlist, is to actually think about recommendation. And when you use the Bayesian pairwise ranking, or just trying on some positive example that you have for a few of the user history, there's some negative sample that is essentially randomly sampling through the catalog. When you move to your test sets, all your test elements will have been the negative sampling elements, which has also always seemed a bit paradoxical to me, but I've made this with how it still works, but you have the low ranking assumption. But I think this is the same principle, because you have something that you train explicitly to be negative samples, but at the end of the day, you have tested this negative sample, because you're not trying to retrieve the user history, but new things that you're trying to listen to. So this is pretty much how I can explain that it still works, that you have a few short examples for the playlists, but that may be in a different place at the same time, and then still get what you want at the end of the day.
But then you say that the playlists are mostly disjoint. Yeah, I'm a bit surprised on that, because I would think that a popular song will be in many playlists, right?
Yeah, but in the selection, actually, in the selection of the playlists I've used for the concept space, I've tried to debias as much for the overlapping, and I've tried to select. Yeah, there is a bit of engineering processing to find some relevant playlists, which I've not included because this is mostly SQL queries and trying to find, not having a playlist that is just one artist and just one track, because this is not so interesting. Having some constraint on the diversity, having more than only 2 songs per artist max in the playlist, having a popularity that is low enough, so then you can retrieve some, for instance, Persian music in the playlist. So and then if you divide the number of tracks and average length by playlist, you can find that there is a very little overlap. It's less than 5% of the track. So in some way, it was built in this pre-processing of the concept playlist to select the right playlist that are have a bit of quality. But yeah, you're right that if we did just select all the playlists at the same time, we will have a lot of redundant playlists with a lot of right error at the same time. So,
okay, so thank you very much for all your explanation. And I had a few more questions, but then if nobody has questions, I can add more questions.
Come back for more.
Thank you very much.
Thank you.
Just to let you know, Tim Miller is asking if you could do something, like the sound is not very clear, so maybe you could go closer to the mic. When, yeah. Anyway.
How will I do that? Okay, I can try to do that. Oh, just for the Tim Miller asking, you can switch my microphone actually to just.
Okay, you can do that, or maybe it's better. But we also need to. Yeah. For the remote questions, that should be.
And when I ask questions, I talk to my microphone. Would that work? That'd be better.
Okay. Anyway, it is a remote question.
Okay, no, but at some point I will ask questions, I think.
We figure out something.
Okay, we'll figure out.
Pass immediately. Yeah, I can try to move further.
You can change. Yeah. Thank you, Gaël. And now, indeed, I will give the word to the other reviewer, who is Tim Miller. More than 16,000.
Can you hear me?
Yes, and can you hear me better with my
Oh,
microphone?
yeah, that's way clearer. Clearer. Thanks. No problem. So thanks so much for the talk. I mean, I suppose I think the process here is I give some comments and then I ask some questions. Is this right?
Yes, people are nodding.
Yep, good. So yeah, I mean, thanks. I think it's I mean, this was a great thesis to read. You've seen my report. It was a really great thesis to read. I mean, it really showed there was some really clear and deep thinking on several of the methods, but also very clearly written and communicated throughout. And then I think one of the nice things to see was this pivot you made sort of halfway through, where it came through more in the talk than it did in the report, I think, where you kind of got unhappy with the idea of feature attribution and you stepped back and revisited really what your work was about. And I think it's a really, I'm going to say brave decision to be on a certain track and be unhappy with it and think, look, I'm really going to step back and now I'm going to pivot my entire thesis, when it would have been easier to just continue on the same trajectory you're on, but perhaps not come out with such a great thesis. So I think there was some really original work in part 2, based on a really concrete context and some particularly concrete problems that I appreciated, and some really well evaluated, some really nice ideas that were evaluated well, such as the attribution score stuff. The second part was, I think, sort of less original work, but more philosophical foundations that I found was really impressive for someone in a computer science PhD. It's really difficult to take, having done this before, it's really difficult to take philosophy and map it to a computing context. And I thought you did a really great job of that. And that part, I mean, I have so few questions in that part, and I found it a really nice read. And I learned a lot from that I think I'll apply elsewhere in my work. I think that as I sort of commented, and this leads into my question, right? The ordering of the thesis was kind of strange, where at the first part you define some explainability, and then you ask really, what should I do? In my report, I wondered, well, could you actually flick that round in the thesis? Because I know that's the journey that you went on, but it doesn't have to be. You don't have to write your journey, or your reader is not following the same journey, so you don't have to do that. But I'm not sure your thesis would make sense if you did it that way, because you would have learned a lot of stuff in what is now part 3 and then not applied it in part 2, and it would look weird. And so I guess this leads into my first question, which is, I think, the hardest question. I mean, if you had done part 3 first, all this philosophical foundation, how do you think it would have changed part 2?
Yeah, that's a very counterfactual question. Okay, so just for the thing of switching part 1, so part 2 and 3 actually in the report. Yeah. Actually, this was one big discussion, and for a very long time, this part 3 was actually part 2, and part 2 was a part 3, and it had started as, I'm going to write a big introduction and explainability and stating, okay, I need to cover more ground. So for a long time, it was switched, these two, and I actually had even an option in my overleaf document where I could switch and change some sentences. As we have seen in this document, we will see in this document. And yeah, I think I'm still maybe undecided. What we wanted, I think, what decided me in the end, maybe not just me decided, but Romain was telling me, you need to switch this part to not frighten the juries reading, suddenly coming into XA and reading 150 pages of philosophy and wondering, what am I reading? Fair enough. Is that maybe it was a bit more of an opening, and I think the twist I gave it in the end of the last chapter of opening on causality and even sliding to chaos theory because it was a bit fun, felt more like an opening. And as you mentioned also in your report, there is a lot of things in this philosophical part that is not translated into the method I did, because as you mentioned, it was a journey. So I think it made a lot more sense, or maybe a lot more sense, but to go in the reverse way in stating, know that we have the background to understand what XAI is or what are the different methods, trying to take a step back from it. But I can absolutely understand the critique that I don't know whether this is a good to switch. Arguably, this is a bit independent, these two parts. And now, coming to your question of if I had started with a philosophy major and coming to XAI, I think, things would have been very different, because I would have lacked maybe the technical knowledge of, going into the mathematical stuff. Just, of course, I'm coming from a very mathematical background. If this doesn't show, I think it shows a lot. So I don't know, there is no telling. I think I would have definitely more focused on user studies, because I would have gone less technical first. And this is something that I'm maybe more aware of after I started to be more aware of that after maybe 1 year of PhD and discovering the FACT conference and all those different people and interdisciplinarity and things like that, that there was not just a technical solution. So this is, of course, everything I've shown is also part of my own understanding and journey going through applying the most cited method on GitHub to then wondering, well, it doesn't make sense and we need something different and everything is doomed, and actually something may not be doomed, and how do we change that? So a lot of 5 stages of grief and different things, and it's still not complete, and I think it's just also the start of the journey on many aspects. So I don't know if I have a good answer to how I would have done things differently for that.
Let me follow on and ask another counterfactual question then. As you said, if you wanted to do more user studies, can you give an example of, what's the sort of hypothesis you would like to test in a human behavioral experiment on, say, chapter 5 would be a good one?
So chapter 5 is concept 1? Concept 1.
Is it chapter? Yes, that's right. Yep.
I think it's this one. So definitely first checking if, so it depends on the, of course, explanation task. And if you're, one thing I really wanted to try is the exploration thing, and stating, just like the taste path paper that I mentioned in the bottom, which was done for Spotify, they had one interesting result, is giving a graph of artists to users. And what they found is actually the best discoveries are found on the frontier of what you know, which I found was very cool to find. And I was wondering, maybe can we do the sort of same thing with this hierarchy, giving that to users, saying what they are evaluating what they are listening to, and stating, well, would this be a better discovery than something else? And of course, also trying to better label these concepts, because there is a big thing that I've skipped is how do you label this concept? Because you use playlists, but there may be a big topic in, does it resonate with how people actually describe music? Because you rely on the assumption that playlists represent a good musical idea, and that the title of the playlist is a good expression of this musical idea, but this is far from straightforward. And I think what we have, if I need to give an example user study, actually I wanted to do one, but the paper was already so long, and the ISMIR conference only allows to some pages with no supplementary material. What I wanted to try is, well, give an audio, maybe first prompt users to describe the music or find what are the interesting concepts, and then maybe second phase, give the explanation that we find and some negative sample explanation, and find if you click on the right explanation to sort of validate that it makes sense what we detect. But then on the hierarchy part, I don't know how to evaluate this hierarchy part, because it's really hard to say that I'm going to show you hierarchy and let's evaluate if you understood it well. And in general, with this user study on explanation is always one of the big questions of how you evaluate understanding, because we cannot go into the brain and check that you understood something if we know what understanding means. And usually you use, of course, proxy evaluation of trying to see if people can better predict, because you suppose that if they understand better the explanation of the model, they can better simulate the model. But in this case of the hierarchy, I didn't really see how that translated. Of course, you can have also self-declared scale of I did understand something better or not. But yeah, definitely designing user studies is an art of its own, and yeah, it's not so straightforward. So actually, I started thinking about this question of how to evaluate this concept thing, but I don't have yet a good answer to this. But yeah, this is definitely one topic that would be interesting to do. If that answers well your question.
Yeah, I mean, I agree. It's a difficult task and a good thought experiment to think it through. So, I mean, I guess I'll ask two more questions. When you talk, I think it's chapter 6, when you sort of have this definition of attribution, where you formalize this definition of attribution. You focus a lot on feature attribution, but I did at the time wonder, well, can't you? I mean, definitely contrastive counterfactual explanations you could probably generalize the framework quite easily to that. But what about even things like rules, rule-based models where you effectively treat, I don't know, the rule or a slice of the rule as something similar to the feature as something similar to a feature, right? As in if the rule doesn't fire, then it's not relevant, but certainly contrastive explanations. And I'm just wondering, did you think about trying to generalize this idea to things other than feature attribution? And do you think it would be straightforward or much more difficult?
Yeah, so I think first, me coming to feature attribution is first because I have also a biased understanding of explainability, and that, of course, these are the most cited methods. So this is why I spent so much time on feature attribution at first, and this was my first entry point to the topic. But the rule-based, I think that I wrote a little something about not rules, but tree, which is somehow similar in the chapter for the ICML paper 1. That you also have some, let's say, specific challenges to the field of rule-based reasoning, because you can find rules that do not necessarily make sense. Also, it's sort of the same problem than XA. Find some rules that are spurious correlation, if we can state it that way. Also, the question of if you have too many rules because you have a big model, how do you adapt rule to the local case? It was not so straightforward, I found. So I don't have a good answer on rule-based reasoning. I think it would be very valuable, for instance, to put on top of the concept learning thing, because you could then reason in terms of prototype and stating that I can combine these two concepts and make these different concepts, or if I have this and not this, I can arrive to that. So I think it's really nice, but yeah, I think my general comment is it's come also with a lot of specific challenges. So I've started to think about it, but I didn't have a good answer yet. So that's why I didn't wander so much on this territory. The contrastive part, of course, a bit more. And yeah, I've seen that I've written a short recap of counterfactuals in explainability, because, of course, it's really hard to avoid the explanation or contrastive aspect of it. And also, if you start talking about selectivity, of course, it's really hard to not talk about contrast. So I've given some thoughts to that, but again, I've not published a paper on contrastiveness, so I think my understanding is maybe more limited than if I had been working on that. And rule-based is the same, but yeah, I don't have a good answer for rule-based and contrastiveness, but I don't know, actually.
All right, no problem. Okay, so I'll give you one last question. I think this will be easier for you to answer. So in chapter, I think it's 4, where you do the masking in the mixture of experts chapter, where you do the masking. How does that relate to, say, using dropout instead of masking?
Because the masking is fixed. So this is just emulating the thing where we discuss with Gaël, with defining the group yourself and say, no, the experts are fixed. But moving to dropout and stating that maybe you can try to learn automatically this group. This is actually how I did try to learn it, having a sort of mask by block dropout and trying to learn all of that implicitly. But this is how you run into this question of fuzzy logic, and because you have a dropout, you have a probability of being masked or not. So you have a fuzzy set and a fuzzy combination of set. How do you define the hierarchy on the fuzzy set? And how do we make sure that, and so this is how I started going into having a lot of losses, putting forward more univariate group at the beginning, in the end. So it can get a bit messy. And this is why I think I also simplified for this first paper and saying, okay, let's fix the group and study well what's going on. But this is definitely, I think, an idea worth exploring to try to learn that a bit more automatically. And this is how I approach it with dropout. And what I did also is a Gumbel softmax trick, if that resonates with what you know. If not, it's okay.
What was the term again?
Gumbel softmax trick.
Gumbels? No.
Yeah, it's like a combination of a discrete and continuous distribution that helps you to sample this kind of. It helps gradient descent on discrete variables. So if you're trying to say that my subset is essentially a big one-hot vector of having 1 and zeros of what is included or not in the subset, you can use this Gumbel softmax trick to start learning these kind of things and putting that into a dropout mechanism to learn everything implicitly. But trust me, then you have some weird training dynamics, and it's really not so trivial to not have everything collapse to a trivial solution or everything using all the features at the same time. So you run into a lot of more technical problem to having that. So I think this is, I did explore a bit on that, but then cut all of that for just a work and left that as further work, further exploration. But at the end of the day, I just kept changing topic for each paper, so I didn't pursue anything I had written in this future work section. But yeah.
Right. Great. Okay. Thanks. Well, now I've learned a term to go and look up, Gumbel softmax.
All
right. Thanks very much for answering the questions, and I'll pass on to the next.
Thanks.
Step.
So maybe you can switch to the other remote. So.
Yeah. Okay. So Markus, I don't know if you heard, but you can ask your question.
Okay. So it seems it's my turn. Okay.
Yeah. Sorry, because I forgot to switch the microphone to one in the middle.
Okay. I see. Well, no, got it. So first, Darius, congratulations on your really excellent PhD thesis. Really enjoyed reading it. So it's very well structured. Also, like this color coding, where you have this different additional auxiliary materials and so on. And particularly, I like your multidisciplinary approach. I'm not much into philosophy, I have to admit, but I've never seen this in a PhD thesis. So it was very nice, even though resulted in quite a lot of pages, obviously.
Obviously.
Many of the comments I had or questions already been asked. I was also kind of, as you might have guessed, because you cited the Lemons paper of Alessandra and my group. So I was also kind of, when looking at the spectrogram thing and your argument that, well, you should not throw a spectrogram to a reader or to a listener because they don't understand. I was also kind of puzzled a bit because I thought, okay, then since the spectrogram is such a low-level representation, then why not just playing it, right? Sorry. What I was a bit surprised, this has also already been touched upon, is that you did not more intensely, not only connecting to philosophy, but also to HCI and in particular user studies. Now, this has already been discussed for quite a bit. And your argument, if I got it correct, is that, in order to really deeply investigate the understanding of the listener, we would need to look into the brain, so to say, what you just said. But I'm wondering, does the user really need to gain a deep understanding from the explanations, or wouldn't it already be sufficient to, in a potential user study, investigate the user experience or the perceived usefulness of the explanations? I mean, at least from the user's value, or probably also from a business perspective, right? To keep the user engaged. So could you comment a little bit on these aspects?
Sure. Well, this is actually a very philosophical question for the purpose of explanations. And I think if you think about the piece by Navatin Taref on explainable recommender, she would have highlighted that you have not only understanding, so I don't know how she frames it, but probably transparency, but you have also persuasiveness if you want to have recommendation. And if you put yourself in the shoes of Deezer, maybe if you want to have an explanation product for the end users, although that would be more devoted to persuading user to click more on the item. And it has been shown that if you just inputting any explanation, have user click more on the items, which is, by the way, also one difficult bias to control, that people are not just clicking because there is one convincing text and instead of something else. I think, yeah, one of the just to mention, I didn't not conduct user studies because I thought it was difficult to do. I think there are many people doing that pretty well. And for instance, at Praxis, you have the Interest workshop by Peter Brusilowski, who is devoted to all these questions. And just to defend myself, I would say that in general, I'm attending this workshop and trying to learn from insight from this field. So that would be the contribution, or being an ally to this user studies realm and trying to be aware of this literature. But definitely this is something I want to do more in the future, to have more time for user studies and learning how to do them properly. And coming back to this purpose of explanation, yeah, I mentioned, but this was maybe a reduction, that you want people to better understand, but there are many ways to approach what is the goal of explanation. It can be to better predict something, but also it can be also instill as better interact with the model. You can have explanation just to have more control, because usually this is the end goal. People don't ask explanation for the recommendation just to understand how the system works, but pretty often to better act on the model. On their interface, and wonder, how can I actually change that? How can I have more of the thing that I like and communicate well with the system? So definitely depend on the case and the context. And I think this is also what shows from attending this workshop for recommender system, that each time you have to be very, very precise about what context you are studying and who are the users and what is exactly the explanation method, the interface that you use. And pretty often you have a lot of things to control for, and that leads to very specific knowledge, which I'm not saying is a bad thing, but I'm saying it's really hard to generalize and to have a well-crafted user study that will tell you that this is how we need to do explainability in a general way. And maybe that's a good thing, actually, that we need to be super specific to each task. And probably in the long run, you will see some trends emerging from what explainability should be in general. So yeah, I'm not stating that the goal is ultimately always understanding. It can be many goals. If you talk about, for instance, fairness, trying to understand if your model is fair. Of course, there are many ways to approach fairness. It can be for the data, trying to collect representative data. It can be in the model, trying to understand what's going on and avoiding or better pushing some mechanism for more fairness. It can be a post-processing to try to re-rank your item, like Christine Bauer did, to push for more fairness in your generations. So definitely a lot of different ways to do, which is a very, I realize, a very vacuous answer, because again saying it depends. But yeah, it really depends on the context, I would say, in general, to how to tackle these user studies. But yeah, going for instance, the psychology grounded recommendation with like the work of Elizabeth Lex, I think in this kind of situation, you may claim that this is a sort of explainability on how you activate the memory and repetition, and trying to see in this context, did we model well how people felt about this repetition count, and did we model well the activation of the memory? So I think that would appeal to a different kind of evaluation. But I can revert the question back to you. How would you evaluate the actor model and with a user study precisely? It's pretty difficult, I think.
Of course, it's difficult. I mean, since you just mentioned the personality or the psychology awareness, I think we and also others have shown that, for instance, personality traits strongly influence which kind of explanations is desired. So I'm wondering, whether or what you think there is obviously a discrepancy between the wealth of research, of academic research done on explainability and on actually their implementation in commercial products, right? What do you think?
Well, the thing is, there are not many implementation of explanation in recommender system and tech industries, which is actually one of the big problem and calling to the rabbit hole that nobody has exploited yet. Of is it actually the good, paradigm to be just serving automatically music content to user instead of having different approaches? Sorry, why am I saying that? Your question was. What was your question, Markus, again? Sorry.
Well, actually, why is there a discrepancy? I mean, this is true also for recommendation algorithms themselves. But on the one hand, there is a vast amount of literature on explainability and also explanations in recommender systems. On the other hand, very few of those are actually adopted in real commercial systems. And why do you think this is the case? Is it because there is no one-fits-all solutions? So actually explanations or the way explanations are given should be highly personalized, or what do you think?
Yeah, so I think this is a big question and also the big, okay, so this is what I call in my manuscript the dilemma of control. And I was coming to this explanation method and stating that pretty often, if you take the point of view of the user, because you talk about the implementing features in the product, so that is mostly targeting the explanation for end users, pretty often what they are aiming to is control, having more control in the app. And one point I was making is, well, if the product owners don't have the desire to give more control to the users, because it can be a bit frightening, to not have an AI that you can control, then they are not going to implement explanation, of course. At least maybe they are not doing that actively and implicitly, but this is also how you slide into the more political and systemic issues of, what is recommendation and the agency that tech companies have in deciding who gets recommending what is a good recommendation. And, so this is, I think, a bigger question. But yeah, to the question, why don't we have more explanation in the product, and why don't we have just, simple labels stating that here is your weekly discoveries because you listen to music or because you have listened to it recently. It's probably have a lot to do with this more, I'm going to say, political or socio-technical question, or how we approach, what tech products are and what AI, because in the more general sense than just the technical machine learning method are. So I think it's a product thing and not just related to the technical thing. I know that, at Deezer, if you try to implement something in the product, for instance, I'm just not talking badly about Deezer, of course, but it's often pretty difficult because you need to balance many stakeholders. Actually, the people in charge, the shareholders, maybe more than the stakeholders, but who have many different ideas on what should be in the product. There is also, what I've written below, the enchanted determinism of AI. This is a very good point by Kate Crawford. If you want to read Kate Crawford, very good book, The Atlas of AI. And pretty often, some tech companies are, feel more confident about giving all that power to an AI that is supposedly superior to human and more objective. And I think what I've tried to push forward in this third part of the manuscript is that, well, objectivity doesn't really exist, right? There are also always some subjective decisions being encoded in those equations. And if you start reasoning about why we have a system that is in place, of course, you slowly slide into more general consideration, right? That would be my general answer to your question.
Thank you.
Politics.
Maybe some more specific ones. I think it was in your chapter 3 where you said that when looking at the skips, what really popped out is that you said users skip their favorite tracks almost as often as other tracks, right?
Yes.
Could you give an explanation why, and also elaborate a little bit on how this does affect your results? So does it mean that there is no value in skips at all, to ask provocatively?
Yeah, but I think it is a great question, because actually how I got at Deezer was during my end of study internship was exactly on this skip prediction task. And it was not formulated as an explainability question, but more how do we predict the skip? And this is, I think, how I got into this question of explainability, that, okay, I can actually train a big transformer model and predict the skip with a relative accuracy, because of course there is a part of not stochasticity, but external factors that you may know about and that you will probably never know. And this is how I got into well, maybe we need to explain the skip, and this is more valuable because you have this implicitness of the skip that sometimes are neutral, and that sometimes actually it's maybe a song that you very much like, but this is not the right context, and say, oh, I love it, but not now, just not Bohemian Rhapsody now at this context. And yeah, so the fav was actually one argument that I also presented to people at Deezer, because some had also this idea of having just one play button, and then you are recommended everything you want without any intervention, and without never asking about the user about what they want to listen to, and putting forward that, well, actually you cannot read everything from data from the skip, but also even from the favorites. The favorite actually activity first are very rare on the app. I think I had computed at some point that it was one track over 100 or 1,000 where you have a favorite. And going to a question of why people skip as much the favorite track as the non-favorite track, because in the case of Deezer at least, but I think in general streaming app, people use a lot the favorite button to bookmark the song, more than just stating that this is a fav and I want to listen to that. So I think this is a problem of, labeling, and again, coming back to interfaces and how people actually strategically adapt to your interface. And this is how you enter the difficult frame of, again, user studies, and how people will react to your product in unexpected ways. So that would be one explanation. The banishing a music is one of the few very explicit interaction, I think. But yeah, for the favorite, definitely this is pretty difficult. And this is yeah, sorry, I will let you talk now.
No, just go ahead.
Yeah, I think this is how we were led to, for instance, at Deezer, just to give one example, we have one feature that is the flow, which is you exactly play on the start, and then you have supposedly recommendation aggregating all your different taste clusters. And we were led to presenting, this thing on the skip prediction and the implicitness on all reading all these signals that are just confounded by so many external factors that we don't have access to and that are very hard to represent. Coming to, for instance, the flow moods, a new feature where we, this is not an advertisement, where you ask a user to what is the mood you want to listen to, or what is the starting, the seed genre that you want to listen to, and asking them, do you want more discoveries or less discoveries in this session, and coming to this kind of features. So this is probably how we are going to tackle that.
Mm-hmm. So again, this is related also to the user interface design, partly at least.
Yeah.
Okay.
Definitely.
I have two more small questions on chapter 5 in particular. If I remember correctly, for learning the concepts from playlists and spectrogram, you use a rather small number of playlists, like compared to the million playlist data set. I think it was just a few thousand. And I was wondering, is this enough to really cover a diversity that is wide enough?
So you're asking about the concept learning thing. What is your question exactly? Is it enough to consider a few thousand playlists for the space of concept?
Exactly, yeah.
Yeah.
There's
So
this larger data sets with, I don't know, you know, of course, from the Rexus Challenge, the million playlist data set. So I see this is already very fine-grained, but
yeah,
I was wondering whether a few thousand playlists is already enough to really capture a wide variety, diversity. And maybe you could also comment a little bit on the biases that are introduced by the users. Okay, you already mentioned here cultural biases, but also on the language. You only considered English playlists. So two questions.
Yeah, okay. So there is a
Is the number of playlists sufficient? And the other one is related to biases. Could you elaborate a little bit more on that?
sure. So I think first, in my point of view, 3,000 playlists was already a lot to handle and to learn from. And because, you know, I mentioned that finding one hierarchy is one chance over 3,000 to the power 3,000. So this is a gigantic difficult task to solve. I think it's a 1 million playlist data set from it's Spotify, right? Or maybe just a wisdom challenge. There is also, you need to know that there is a lot of redundancies and people, you know, publishing essentially what Gaël was mentioning, the top tracks and having the popular tracks. So what I did is how I arrived at this 3,000 playlists is first considering all the editorial playlists that are supposedly crafted by experts and should show diversity. But actually, they don't cover all the countries and all the cases. And this was already maybe 2,000 of the playlists are supposedly well crafted by the editorial. But I found that there were some misses on some countries. So I also fetched, that's how I resorted to the user playlist to have a bit more diversity. But you know, I don't know if 3,000 is not enough to describe music in a sort of general way. I think it's already a lot to handle and to, you know, exploring this hierarchy is pretty daunting already. But
from the empirical findings, it looks like it was just about the numbers.
yeah, and maybe we need a hierarchy of hierarchies to explore that in a more efficient way. And yeah, coming back to your question of cultural and model bias. So cultural bias, there is actually a lot of talk to talk about for using playlists, which was, of course, by the way, not the only idea for learning a concept. There was actually another paper published at Izmir by someone from GKU, also Francesco Foscarin. I don't know how you pronounce it, but on computing concept from the MIDI sheets and not from audio, and having a different approach, which was really interesting. And yeah, for the cultural bias, for instance, what could go wrong with playlist is you have a playlist that is the OST of Stranger Things, which has a very distinct concept, which is 80s synth music. But then if you look at the title, it's just Stranger Things. And if you don't know what this is, you say, oh, why is it my song similar to Stranger Things? It doesn't really make sense. So you have the OST problem that are very common for playlists. You have also some hidden confounders, as I would call them. So this one, the City Sounds New Orleans, actually were very confounded by the taste of the curators. Let me move this. So you have Naples and Havana. No, what's going on? And it was essentially 60s rock music, because that was the taste of the curator, and stating, okay, what are the 60s rock music in Naples, Milan, and so on, which doesn't show in the title of the playlist. And so this is also where the big assumption of does a playlist represent always a musical concept start to fail, because it is sometimes true, and sometimes you may have more external factors relating to how you build this playlist. So this is definitely not a one-to-one mapping. And sorry, moving finally to the model bias. Yeah, you mentioned the speaking language. And this is actually a good remark because, okay, going back to this slide. So we rely on a backbone to detect the concepts. But so the one we use is a famous musician model that we use a lot of time at Izmir. But for instance, one thing that musician cannot do is detect the spoken language, because of course this is also a difficult problem to detect the spoken language from spectrograms. So, for instance, it cannot distinguish between a British jazz and Japanese jazz, which could be useful, you know, to discriminate if, in the ideal sense, you would like to have a general decomposition of music. But yeah, this is one of the few problems with using concepts. So, but yeah, it was maybe the trying to explore what's going on. But yeah, there are many drawbacks or, you know, insufficiencies with doing proceeding with these methods. To give you some examples.
Sorry, I didn't get the last part.
No, yeah, that was I was finished on
okay, thanks.
model biases and cultural biases, but there are many more that, of course, I'm not aware of. But that was a few of them I could list.
I think we keep talking. Could keep on talking about biases for an hour or so. But since we have the time, maybe just a very brief last question. I think you already answered it to some extent, because when I read it, that you're using playlist, I was wondering about their consistency or homogeneity. So, for instance, there are a lot of playlists like just called, you know, my favorite songs, or songs starting with a specific letter even, or quizzes or something like that. But as far as I understood, you foremost focused on editorial expert created playlists. So this was not an issue, I guess, or did you filter them out, or?
Yes, there was definitely a processing step that I did not mention. But okay, so first having the editorial, you're pretty sure that there is good quality playlists. But then moving to the territory of user playlists, you have a lot of dumb playlist name and a lot of things that are, of course, the favorite. So yeah, that was one of the filtering, to not have a playlist with my favorite or top songs that you had top 100 already. You have a big chunk of Deezer playlist or my favorite song or top 100 of a country. I mean, you can select some of the top 100 of a country to have a good diversity, but then be done with it and move to trying to detect more playlists. So yeah, the pre-processing thing it's again just a big list of SQL filters and trying to inspect manually what you retrieve as a playlist and stating, okay, maybe this is enough. Oh, I did not consider the OST playlist, and no, I have to retrain again. So yeah, it was a manual me fiddling with the playlist and trying to find some good filters to have a bunch of good users playlists, at least in the representativity sense. But yeah, it's not a perfect process.
Yeah, of course. But this was actually not described in detail as far as I remember. But I thought that this must have been a lot of work.
Yes. Yeah, I didn't want to, you know, embed this is a big SQL query that I did because I didn't find it was so interesting. But yes, there is a bit of work on that.
I'm sure about that. Okay, thank you very much.
Yeah, thanks, Markus. Let me switch microphone.
So now we'll give the word to Christina Bauer. How much time do you have for questions? Forever. Great. Oh. Yeah, now it's time for the really difficult questions. So finally we are there.
Finally.
So I like promised to ask difficult questions, so we'll do so. Some questions were already a bit difficult, they were already asked, so I don't ask them again. I really like your work so much because like also you looked at it from different angles and tried to answer some, and you also found out and reflect on that you couldn't answer some. And what all has in common is it's about explaining about what's happening or to interpret what's happening. And I wonder how one can build a new approach, if at all, and what needs to be done differently to explain why something is not recommended. So, for instance, if as a developer to find out, well, why are certain groups of songs or artists not recommended at all, or not certain groups, or also from the user perspective, why don't I get any jazz songs?
Sorry?
Why don't I get any jazz songs? So why is something's not happening? Can we build on your work, and how not?
Okay, so let me switch microphone. Will answer and switch microphone for people online. Yeah, so sounds like this is also a counterfactual question of why this instead of this. So I didn't study much the counterfactual explanation. I think that, for instance, people like Thibault Logel, I think was varied by you, was more into this question. Hello, Gabriel, arriving right on time. So yeah, I think it's a different setting, and I don't have given much thought to this exact question of what's not gets recommended, but I will just underline that there are many also non-related to recommender system problem, like what is recommendable, which is also a big topic at Deezer, because one of the common issues is you don't have enough interaction to build a model for computing embeddings and so on and so forth. And of course, because things are not recommended, then they don't get any interaction and they stay in this long tail of items that have only a few interactions. I think my answer would be actually to not use explanation method, but maybe more exploration tools and giving, again, moving to the product and having, if you think in terms of the users, of course, having more tools to explore the music, which in my personal opinion as a user of this streaming platform is a big miss, that it's really hard to explore the music in an active way, not stating, oh, I want to listen to jazz and then being recommended, or to be more active more than lean back. So maybe the answer is not in explainability, and then we can start to foster different things. But I will also highlight that this is also not an impossibility, in my opinion, to recommend unpopular track, which is also one, in again, opinion. Many people, I think, in my team will maybe disagree with that. It is not a fatality to not be able to recommend unpopular track if we just very naively, randomly sample in the catalog from time to time and have one song over 10 that is, okay, maybe not completely random, but a random jazz track. Maybe that's how we could get more interaction on this track, and at the end of the day, be able to build embeddings. Also, you are still able to build embeddings from reading the audio directly, but this is a question of computational power and processing all of that. So again, this is a product decision and more political than just being objective or technical. Of course, there are some technical underlying motivation that is harder to not recommend or not recommend something. I think there are some solution already, not necessarily explanation method, but very simple one that is now a product question, I would say.
Also from more direction, like how is it any possible to build on your work and do something? No. Particularly now from the perspective of like when you read Deezer and you find out something's just not happening. Yeah. This explanation would be actually very good why it's going on. Can this kind of work you've been doing, like, is this useful for building on that and improve something, or is it do something different?
So actually, one thing I wanted to do is use this hierarchy of concept and sort to maybe try, this was just an idea, but I've not at all started to implement it or ask people to implement it, but maybe starting to seeing the trajectories in which recommendations are made, for instance, stating that, oh, we are going to start exploring this branch, and saying that, oh, people are skipping a lot this music, maybe this is not the right mood, maybe we need to go up in the hierarchy and explore a different branch, and having this sort of more dynamic use of recommendation that can adapt live, maybe even let people choose manually in this hierarchy. Of course, this is very not convenient to explore on a phone, so there are many problems again coming to interfaces and making that clear to people who would be using that. But yeah, I think this is one of the things I feel the most promising, the concept learning thing, because it's the more aligned with, if you think about end users, how they would describe the music and how they will explore that. I think the spike thing is maybe more linked to technical people. But actually I had some preliminary experiments. So on this Deezer dataset too, because I mentioned that spikes were communities, trying to label those communities. And one work I started to do is finding, for instance, a playlist starting to fuse several works. The playlist that was the most present in these spikes, and maybe having several playlist titles and doing some frequency analysis to find the most frequent quick keyword and naming these communities. And then you could propose to switch to a different community, but you could frame that as either concept of music or whatever the keyword is more understandable to user, or stating you're now in this community of recommendation. There are those close representation if you want to switch gears, or maybe explicitly say I want something more jazzier. I think that people in the room who would be very into large language model would probably raise their hand and say, yeah, we can have a chatbot stating that. Yeah, I'm a bit in two minds about large language models, but definitely there are, possibilities for this kind of things to happen, to have more direct interaction and asking directly why this instead of this. Yeah. So yeah, definitely the first two works are more on the theoretical side of feature attribution, but these last two are way more practically grounded into the music things. But it's not a finished product, I would say. It's
another question relates to actually to your recipe, how to do things, like to make good explanations. And yeah, so I'm challenging some points in there.
okay.
Because in point 2 you say to ask the question, is there risk of persuasion or acceptance, so from the explainer part. And I'm wondering if it's really a bad thing or not a bad thing when it's targeting like a user, so explanation to user, because maybe I'm challenging that it's fully okay to say something that's not completely true, but true somehow. So for instance, something is recommended for a reason based on the model, but in the end you can find other similarities, and that's easier to understand for the user. So it's true or not true at the same time, and yeah. So what's going on here?
Yeah, that's a very good comment. Yeah, I wonder the same thing. I had written something in my manuscript for this persuasion thing, and what is, what are the different type of persuasion, and is it a good or a bad thing? And it's true that often when we say persuasion, pretty often, at least for the general opinion, you persuade someone to do something, it's often framed negatively. But in the literature of recommender system, it was rather framed positively. Again, coming back to Navatin Taref, who talked about this explainable recommendation and how to persuade user. It was actually at the start framed as a way to encourage people to click on an item by making things more understandable and thinking, oh, instead of this is going to be a cluster number 3, oh, this is going to be rock songs. So, oh, yes, maybe I will click and explore these things. And this is indeed something that I had noted, that maybe if your method is bad in the beginning, because again, explanation is a process, not just the production, maybe you can start with something bad and end up, because of strategic adaptation and how people, appropriate this tool, with something that is beneficial for understanding and exploring new territories for music. So I'm not settled on this question, and this is definitely not a binary answer of do we want persuasion or not, but for the purely explanation part, there is of course a big problem that's actually been discussed by Tim Miller in this recent piece at Fact, the XAI is dead, on the either over-reliance or under-reliance on the explanation, and the over-reliance being this thing that was also mentioning by Paul Essan, where you have some numbers and you trust the number, you trust sort of blindly or naively the explanation, even if the explanation doesn't make sense. But I actually read that, yeah, there are many components to what is the good for the user, and maybe it can be good for music labels or for some artists to have that. So trade-offs, as always, to explain, yeah, to persuade. I don't know if this is ethical. This is yeah, I think there is some dose of persuasion that will be okay, And if you think goes back again to Aristotle and the art of rhetoric, when they describe the persuasion, it was often framed as you have the logos, logical argument, the ethos, the credibility, and the pathos appealing to emotion. And it was not framed as something that is positive or negative, but more how you convey your ideas and how. So you could also frame persuasion as how you transform, this transformer and a big result into something that is digestible to humans. So that could be a way to frame persuasion in a more positive manner. But of course, there are many problems with persuasion. And if you come back to large language model and hallucination and gaslighting, if we can really apply that to model people into thinking that this is the right solution, and I'm not lying to you, and this is definitely not an hallucinated result, of course, you have a range of problems. So maybe persuasion is not precise enough to, really discuss what could be good or not in using that.
Other kind of explanation, but other kind doesn't necessarily mean that it's not true for some, but it can be true, but look at it from a different angle.
Yes. Yeah, I'm switching microphone all the time. Yeah, definitely. I didn't actually bounce on Markus Schedl answer for the personality base, but this is, definitely many works are studying these big 5 traits and how the recommendation perform different depending on the group of users. You can also extend that on depending on the culture and, did we label music correctly? Because sometimes the label do not make sense depending on the culture. What we define as rock in France, where we have the most larger basis of users for Deezer, may not mean the same thing in Japan. Actually, it does not mean the same thing at all. For instance, what in France we call the, how do we call that? The world music, which is often the quote-unquote African music, taking as a whole, is not precise enough. And if you go to users in different countries, you have more precise terms. Same with Brazil, you have a lot of declination of different things. Gospel has a completely different meaning in Brazil, for instance. So definitely this is, again, context grounded, and we need a more encompassing approach. And this is very vacuous to say that, but as again, it's always the same, the reasoning. We need to consider all the stakeholders and to potentially how you perform. You may not be able maybe to satisfy everybody at the same time, but at least trying to do it is, I think, a good direction. Instead of sitting, I will just have a mass of users and recommend and A/B test that 50% are satisfied.
There, because like concerning the concepts, like the approach that you take to derive concepts that you use for the explanations. And now you mentioned something, maybe there's something cultural difference or context or whatever angle. And I'm wondering if you need to have to adapt at the starting point, just things like when it comes up to something's recommended because it's also rock. And then some users say, but that's not rock, that's pop, classical pop, it's not rock. And especially with rock and pop, is there, for certain people, you can have a debate for 3 hours, whether something's rock or pop. And there are cultural differences, like in US, something's more easily rock than it is in Europe. And then there will be other differences. How to deal with that? Like, you need to start from scratch and separate.
I don't know exactly, but it's true that if you go to Izmir and talk to musicologists, they will quickly tell you that labels were invented by record selling companies to classify the music more than, describe accurately what music is. So this is definitely one big caveat for this hierarchy. I wouldn't be in a total relativism position and say that everything is subjective and maybe this rock for me is classical music. Maybe this is not so. There is probably an in-between truth that is adapted to each country. I guess that's one potential solution, but that would require a lot of data, is adapting to at least on the country level, maybe, and trying to do some transfer, how do we say that, transferring the knowledge between, maybe learning between the several countries and having some specificities, maybe that's one approach. And of course, you could also question, this is maybe leading to a different question, the normativity of, staying is your filter bubble of country and having this world music as concept. And, oh yeah, the world music I like listening to, and maybe, showing more general concepts that are more inclusive could be also, big question of should we adapt to every country, which is, a big question. I don't have a good answer to it, but as usual, we need to decide that collectively, and because there are many solutions, and what are the good principles or the good norms that we should put in place. It's not just me as a PhD to decide, but it should be more democratic. And this is also why I have a big chunk of my manuscript arguing that this should be more participatory. We shouldn't be the one to decide here at Deezer or even here on the scale of Izmir, because sometimes, I attended one workshop during the unconference at Izmir, and we were talking about human alignment. And it was a bit strange because there was only white male in the room discussing human alignment, and stating, oh yeah, but the big issue that people need to be educated. They don't understand machine learning. And I was wondering, and maybe we also have our biases. We are not higher than the users, and maybe there is also some knowledge to gain from how people approach recommendation from record label. If you talk to artists about recommender system, that will have a lot to think to say, I think, about how what recommendation should be or should not be, and yeah, echoing the work. But yeah,
I like this question now. Just came up with that because I'm also wondering, maybe it's not that you would need a different hierarchy for every country, but just different label that you display to someone. So just not saying that it's rock pop something, or just saying something different, which is true and not true at the same time.
I agree. But sorry, switching microphone. No, yes, how to do that. I think there are so many issues already with just having a working hierarchy, because it was done computing hierarchy from audio solely and not using any source of data. So hierarchy is not that good, right? There are many things that works globally, but if you look into the details, there are a lot of errors. So there's already a lot to do for just one country or just for the world, for making sense of how everything is organized. It's already a difficult task, but yeah, definitely trying to adapt to each user, even its level of expertise could be a good opening, but I don't know how to perform that. That could be a cool idea and further research direction, I guess.
Final question is open.
You already open up to this. So there are topics that need to be done by other people. So my question is, what is like the big hot topic that needs to be done by the next PhD? And I like to hear some specifics, because we're always like starting after PhD before a new one. So what does the next one have to do to build on your work?
To build on your work, I don't know.
We can stop now. So
we can stop now. I guess of course, generative model part is one hot topic at this time. Everybody's talking about LLMs, ChatGPT. So I think it comes with a lot of different challenges that really needs addressing. Detection of deepfake music is also one big topic that I will actually be studying after my PhD. So that's why I'm leading into that. For explainability, I know, because of course, if you start a PhD, you have to start from zero again. For me, yes, there is a concept learning part is a really good paradigm that can lead to more human alignment than the more traditionally technical things. Causality also is one recently hot topic. I mean, it has existed for a long time, but only recently in conferences you see more and more, at least in my short life as a researcher, more and more research conducted on causality, saying, oh, maybe we need to have more data to have causal graph. computing the real counterfactuals, where you change something and intervene on something and everything changes the graph instead of just changing one features. So I think this is one of the promising direction, causality. Even if also causality, there are something that are not perfectly clear because you cannot always represent with a directed acyclic graph, and there are many more questions about what causality means, which is also a different topic. Yeah, so concept learning, causality. I think, yeah, again, coming to Markus and Elizabeth Lexi, psychology grounded approaches, I think are very promising. Yeah, so this one. Oh, actually, I did sum it up. Yeah, psychology grounded approaches, I think, are really, at least to me, appealing, because trying to model how actively our cognition works, how we appeal to memory or exploration, how we try to think about what expertise means, I think could be promising to have this kind of different approaches.
Thanks. We have 4 PhD topics. That's great. So
Employs more people. Thanks a lot.
More people in politics. Thanks.
Yeah, and thank you. So we will keep the work for myself as a member of the committee, not on the So I will ask my questions. So you already had many of them. So first, let me congratulate you as well. Thank you and your supervisors for inviting me to be a member of the committee. It was really great. Right? I really enjoyed reading the manuscript and attending your presentations. So thank you very much. As I said, you already had really many questions. I still found 2 different ones I could ask. So many others, but I will put them. First one, because you showed, I think, on slide number 57, you said something which was quite surprising to me. You said that local attribute declarations must have a global coherence.
Yes.
And this is not so obvious to me. Because a question would be, instead of saying that you have this attribute which is relevant, you could say locally, this attribute is relevant. And then you could deal with some contradictions if you specify to the user that locally this attribute is relevant, but locally on another position, it's not that relevant. So do you think there would be a possibility to have indeed contradictions between the local attributions if you specify?
Yeah, but I think I've built this paper exactly to critique this position, which is more the Lime position and Shapley value, not Shapley values, but more the Shap method, and stating that this is, of course, the way that people conceive, again, saliency maps, it's the same, or smooth red is local attribution, and just look at the function at some point. I think this is one of the critique that I try to make, is that this is probably not... I mean, this approach has issues because of these coherency things. And I didn't present that much the other method like selector predictor, but for instance, selector predictor, they have exactly this sort of philosophy that you have a selector that will select the relevant features and the predictor that say, oh, I will use these relevant features to make my prediction. So this is sort of the same reasoning underlying that. But because they are under regularized, what you can end up with is a selector encoding the prediction label to the selection map, and then the predictor just decoding this binary label encoded and making the prediction. So essentially, the model can game the system, and while you are expecting to have this local attribution that will just depend locally on that, you end up with something that has nothing to do with what you wanted initially. So I think my answer to you would be that if we just think locally and not having this global coherence, there are a lot of degenerate solution or under-regularized solution. And maybe this thing of global coherence is one way. I'm not stating that this is the ultimate truth for that. And in fact, I have many examples where this doesn't always work, this local dependence framing. One way to at least better, regularize this model and have more relevant explanation, at least from the standpoint of functional dependencies. And actually, this is one of the open questions that I had on for the evaluation, stating that yes, because we defined this local dependence theory, so which was based on actually set theory and coming back to the definition of a function and stating you need to have a unique image, and this is how you can define the notion of a function locally. But this is again one definition which proves useful to discuss the different methods. But is it then the only solution to describe what's behind the method? Of course, it doesn't address this, for instance, counterfactual explanation. This a bit evades this realm of local dependencies and you need a different approach. Or again, coming back to what Tim Miller was mentioning, rule-based explanation do not at all fall into this sort of paradigm. But I think it was useful just for me as someone reading the research of XAI to understand we have the list of all these methods, what unifies them and what are the different assumptions, and and having this local dependency view helped with finding that, well, the LIME is actually can be viewed as a heuristic to this local dependency problem, which is interesting to think about. Oh, because it's a heuristic, so from an optimization standpoint, you need to check that your heuristic is actually close to the quote unquote optimal solution that is an NP computation, because feature attribution often is NP, non-polynomial. And yes, I think I will end my answer. I don't know how to finish this answer. If you don't stop me, I will start monologuing for hours. So yes, 45 minutes is, it sounds long, but it's short.
Things which are in the manuscript is that actually very often you motivate the need for explainability with the question of fairness.
In the presentation, yes.
Yes. And this is a big question. Do you think that, can you elaborate on the question about how explanations can really help fairness? Because as you just discussed, there are cases where you can have several explanations and then you can choose the one you think is fair or something like this. And can you please comment on this?
So for the user study part, evaluating fairness, you mean choosing between the... Oh, yes, as a motivation for fairness. Yes, I think my angle was more to say that what are the issues with recommender system. I think when we discuss music recommender system or streaming in general, this is one of the topics that comes all the time, that you have a problem of representativity and fairness and artists not getting recommended. This is one of the hot topics. And there are, of course, many ways to address fairness. There is a good piece in AI magazine, I forgot the title, but it was something like the multi-sided market, fairness as a multi-sided market. I forgot the authors. But essentially is, okay, so there are anything, fairness is a big discussion. But essentially, you can categorize the method as is pre-processing, in-processing, and post-processing. And I think the explainability, at least because often in XAI we explain a model, will be more drawn to this middle part, the explaining the model, because if you better understand how the model makes a prediction, then, for instance, for the compass model, if you discuss about this one, seeing that, oh, this is linked to an ethically problematic, this one. Ethically problematic features relying on sensitive attributes, and we don't want that. But if you want to say, if we rely on sensitive attributes, that's how you can get to feature attribution. And do we actually rely on these features and even causality, because it can be in very insidious, indirect ways. So you have the direct dependence and indirect influences. So that's, I think, how I framed it going to fairness. Because even for, I think, engineers at Deezer, you want to check that your model is somewhat fair or somewhat not relying on a sketchy, reasoning that will not have anything to do with music, but more on maximizing, I don't know, something else. So, of course, this is, talking about fairness is talking about biases, and, discussion of biases is gigantic. You have, I think the main one in music is also the bias of popularity. So you can see fairness from this angle of being more fair to less recommended artists or more niche artists. But there are many ways to approach fairness. Also, something that Markus mentioned, being fair could mean having the same performances for different set of users, several personalities. You discuss that from the angle of countries. And I think that from that angle, explainability can help. It's not the definitive answer, but trying to open a bit more the hood of the system can, of course, give some insights. if we can generate them well and they are, relevant. And this is how we come to the what did we actually explain, and is it actually just a meaningless number, or do we really explain what's going on either in the data and the model? Because the big topic is, do we explain the model or the underlying data, which is a big open question. But yeah, so I believe it can be one tool to help explainability.
Risks, for instance, as you said, the question of correlated features is also a big problem, and I want to have some. Okay, this is a big question. Just we'll stop here, and then I will give the word to the supervisors.
We start. Are we on the right mic? Yes.
Yeah, normally.
Okay, so first I want to congratulate you, Darius, for all the work you did. So as mentioned by the other jury member, you really did iterate on problems. So you managed to address some problem and then see the issues and then move forward and then build a whole story about what you wanted to say, and not like digging in a very specific direction where you could have I don't know, got the maximum publication on what there is in this specific topic. No, you wanted like a broad view and address the work problem, and even you were able to take a step back and don't see, so it was also mentioned by the other jury member, but don't see the problem as a very specific computer science or machine learning topic, but in the broad perspective of science and even society, because you're also interested in ethical topic and all the philosophy of that is involved in your work. And I really think this is a very big contribution and a very proof of what to say that being too much, but it was very good. It was very smart, and it shows that you're very mature in your research work. Your report, so I had a lot of pleasure reviewing it, proofreading it. Not only pleasure, but I wanted to elaborate on other emotions. The presentation was also great, like a lot of pedagogy, and you put a lot in it. Like there is so much content in it. But I think you made it sufficiently smooth so that people are able to get what you want to transmit. So also congratulations for that. And and there are also other parts of your work that are not in your manuscript, not in your thesis, but that the team is aware of, the team at Deezer is aware of. And also thank you for that. And you know what I'm talking about. So I don't think I will have a lot of questions, maybe one question. So in equation 413 in your manuscript, obviously.
Yes, I know which one. Yeah, thank you.
So maybe a broad question about what you did in your PhD. So what is the thing that you haven't done and that you would have wanted to do? What is your biggest regret in the PhD? Please do not mention me in the
ruin my next joke, I think. Then yes, I think. Well, I've asked myself this question, anticipating the defense, and that I was going to be asked, what would you do differently for its PhD? And I don't have such a good answer, because if you don't know in advance the journey you're going through, it's difficult to anticipate. So I think I liked the journey I went through, starting mathematical and then opening to different topics. Again, as I mentioned, one big miss, in my opinion, but we've discussed that, is not doing a user study. So this is also what led us to doing a partnership with Bruno, more to the psychology-funded topic. Internship. And yes, I think I would have liked to go more into getting more experience into user studies, because I think there is really, I'm stating it again, the science to doing a good user study and reasoning into what is your good user study, controlling for everything. It's not straightforward. Yeah, I think I would have liked to do that, but I still have time to do it in the future. If you want. Yeah. Yeah, I think that's maybe more on the human tree side. Like I would have loved to have a complete pipeline of inventing whatever you want to frame an explanation method, then interface application, and then checking with user that the whole pipeline is working. But there's only a limited number of years, you can do everything at the same time. So this is how I approached it, seeing several modalities, but yeah, definitely there are several possible journeys I think through this question, which is actually interesting. And there are PhDs, I don't know if Alessandro is online too, but many people working also on explanation of either just recommendation or music recommendation, but we have completely different approaches, and it's really nice to see also, yeah, it's different paths that people can take for this topic. Because yeah, we mentioned it was very, maybe we stop talking, but yeah, this is very multidisciplinary, so I think you can approach this in a number of different ways.
Thank you very much. I won't ask any other question because I already asked many questions along those 4 past years. So again, congrats, congratulations for all that. Thank you also for those for those fantastic 4 years. Unfortunately, it's not over yet. We'll see each other again, I guess. And yeah, I will let. Yes, I don't know if I will let Vincent talk there.
Okay, so on my side, I have definitely no question. Just tell you a few words. Yeah, first of all, congratulations. I think it was really nice and I enjoyed it. It was, yeah, 3 really nice years, full of ideas and projects and contributions, and yeah, it was great. Now, regarding you, yeah, I think you're a great speaker. Very nice presentation, and okay, you focus on the message. It's fun. It's great. Probably you are even a greater writer. It's really nice. Just a short story about the Izmir paper, because you wrote it and it was nice. We have several remarks, but few remarks. And next week you almost rewrite it all. So we say, oh, okay, now it's great. And the week after, you rewrite another time. And so we had to say, please stop. Fortunately, it was still good. And yeah, I think it's the only time in my whole career I have to say to PhD candidate, please stop writing. No, but if I had to mention one quality, I think it's curiosity. All your contributions are incredibly dense. You put so much things in every paper, with opening several follow-up that you never took. Yes. Each time you choose to move forward to another subject, and yeah, it's a great quality, and I think this was why it was so pleasant to work with you. So thank you.
Yeah, thanks to you also.
Thank you very much. So some I would perhaps have other questions, but I think but if you wish. Okay, so I think now the jury will.
Yeah, maybe we'll stay here.
Okay. So and everything.
Yeah.
Do you want? No, I cannot.
No, I have
another. We share it on.
Okay. Well, thanks to everyone online. Oh, actually, there is Alessandro. Thanks. Benjamin was going to show you. Okay, so thanks to you, Tim and Markus, because I don't know if I will come back to you. I will? Will I?
At the end of the jury, we will maybe in the basement there is no internet. If there is internet in the basement, we can move there. Yeah. Yeah. Okay, we will make the announcement here.
Okay, so no thanks to you yet, but later I will do. Okay, so thanks everyone, and we'll now try to cut the YouTube live and other things.